Hello again. This is the setup for the demonstration 2. And of course this is the Power Plants and Processes course at Aalto University. Our system contains a water kettle. This is the amount of water, roughly 900 grams of water in the kettle. Then there's a thermocouple, so we are measuring the water temperature, and the reading for that can be seen here. Then this water kettle and the electric heater is on a scale, as you noticed already. That gives the mass of water. Then we really measure the temperature of the water, and in addition to this we measure the heat electricity, heating power at the moment. And the idea here is to study or form the mass and energy balances for the system, and then we do the measurement. We try to see how the model and the experiment, how they go hand in hand. Okay, only thing is for me is to do now is to turn off on the stove. I put it on full power, and you can see here is the heating power, 1.95 kilowatts. And I will hold the screen here constantly so you can follow the weight and all the other measurements at the same time. So this will take a while. I'm not talking, just wait. Well, I could talk a bit here also. So what we will do by analyzing the mass and energy balances is that we will following the mass. So when the water gets heated, it's evaporated, of course, and the mass is decreasing. From the energy balance point of view, you could think, and we will think, what different terms are there in the energy balance equation. So we need to think if this is a steady state process or is it a transient process. For example, if we consider the heat losses from the system, are there any difference between the heating mode and the boiling mode? You have probably all boiled water, so you know that something happens with the temperature during that period. But okay, let's still follow this, and you should also record the time while watching this, so you can take that time from the video easily. What you see is temperature is increasing. There's not much happening with the weight so far. How about the power? That's pretty constant. Okay, now you notice a bit change in the mass of the water. Temperature of the water is 1550 degrees Celsius. And how about the power? It's pretty constant still. And now if we take a look at the surface of the water, you notice there's steam coming already, or vapor, water vapor. So it tells us that the temperature is there increasing and the vapor pressure of the water is increasing, so it's evaporated. And yeah, that was my feet touching the wire, so this is the correct. Wait. Temperature is already 70, over 70. And from the surface you see that there's already, on the bottom you see already small bubbles are being generated. And you probably hear now a hissing sound, so it starts to boil. Let's follow the temperature and the mass. So temperature is 85 almost. Mass is, I would say the rate of mass decrease is slowly increasing, and the power consumption is constant still. You see that the water is almost boiling and the temperature is approaching 100 degrees Celsius. That's the boiling point of water at atmospheric pressure. Okay, I raised this a bit so maybe I can. So the water starts to boil, I would say right now. So the temperature measurement starts to give us the 100 degrees. Now, okay, now it's about 100. So now the water is boiling. And this is the mass loss, or the mass of the water when it's boiling. Okay, what's the power? So this is pretty constant, so a bit smaller than earlier, but still not far away from the initial value. Here, when it's boiling, the water, the temperature is no longer increasing, but the mass is much faster decreasing now. And from the surface, if you take a look at it, it's very heavily boiling, so there's lots of steam bubbles coming. And so, okay, but this was this demonstration, so we also talk this over the lecture.